Again, scan, skim, deep close, vocabulary inference, textual inference. You come in. I'm going to contribute a little bit on this because you already asked, what is meta-analysis? Okay, guys, meta-analysis, it's not a procedure that we use in engineering. It is used in the medical field. The meta-analysis, if you heard a little bit about it during the COVID pandemic, they were doing a lot of meta-analysis to prove the efficiency and the efficacy of vaccines. And so what is going on over there in the medical field? They have a rainbow of vaccines. Different laboratories are creating different mixtures of vaccines. Okay, and they have to know the efficacy and the efficiency of each one. And the meta-analysis is going to tell you which ones are efficient and which ones have efficacy. Okay? Doubts with this? No? So what is going on here? They are not testing vaccines. They are not testing treatments. They are not testing nothing from the medical world. They are testing literature. They're doing a literature review and using meta-analysis to tell you what is efficient and what is has efficacy. Okay? But not for medicine, for the literature review. Okay? Meta-analysis. This is what I want to share. Guys, there is not a single defined methodology for management or industrial projects. The steps that you see there, you can use some of them, you can add steps, you can subtract steps. There is not one methodology. The methodology that is right there, it's from Calling from 2007. Okay? And so it has 6 steps, but in engineering, we don't have like, this is the correct one. You can add more steps, you can take steps away, you can change steps. Why? Because again, it's a method that comes from another part of the science. Okay? Okay. Story. Do you know Nintendo? Yes. Do you know the first console that Nintendo sent out to the market?
Yes.
No, before that, in the 70s. Do you know Mr. Game & Watch?
No.
No? You haven't played Smash Brothers?
Smash,
yeah, there's a character which is black, yes, and has pants and then sometimes an octopus. His name is Mr. Game & Watch. That's the first portable console that Nintendo came out. Before that, Nintendo was a company that was creating cards, board games, and other toys, physical toys. Nothing to do with electronics. But an employee, a technician at Nintendo, he didn't even get into university, but he was studying electronics by himself. And so he came out with this new apparatus, this new little portable game console. So back in the 70s and in the 80s, we used to have stuff like this. A clock, but they were digital clocks. Do you remember this clocks? What were the functions? What was the functions of a digital watch in the 80s and the 70s?
Calculator.
Yeah, what else?
Chronometer.
Chronometer.
Remote
control. A light. Yes. So this guy, he was studying all of that. And he was working with other people at Casio, at Sony. And he started to think, okay, I can bring a product that uses electronics, but not for the watch or the calculator. I want to send out a game. And so the first Mr. Game & Watch, it has a clock, it has an alarm, and also it has the game, Mr. Game & Watch. And other games, there's also a Mario game. Covariance, we have to talk about these, guys. Covariance, Maybe from your statistical classes, you know variance, and it's the variation within the data. And covariance, it's talking about 2 or 3 measurements, and they have the same variance throughout the system. Something happens to the system, there's an input, and the variance in these measurements, they behave in the same way. And this is very different from correlation. And a lot of people confuse correlation with causation and covariance. So covariance, they are correlated. They are behaving in the same way. It doesn't mean that the one variable influences the other variable. That it's called causation. This is the most used example. In a study, somebody said women that have horses and that take horses lessons, or horse riding lessons, sorry, they have excellent health. They live a long life. And so some people would say, oh, if you want to live a long life, if you're a woman and if you want to live a long life, you should be riding horses. You should be learning to ride horses. And that is a false equivalence. That is not that is not the causality. What is the causality? Women who have money to pay for horses and for horse riding lessons, they also have money to pay to go to the doctor, to pay for treatments, to pay for medicine. And so, yes, they are correlated and they have the same covariance, but they are not, one doesn't cause the other. Having money is what is going to give you, you're going to be able to live a long life. Yes, that is the causation. Yeah, but the covariation is, they spend more money on health and on horses. Okay, I also think it's the most important, which is number 10. Sufficient, well-allocated resources. And guys, you were talking about this. You were telling me they give you this little thing and they want you to go to the moon. This is sufficient, well-allocated resources. And I'm gonna give you a story. It's not my story. It's about an ex-president of the United States, and also he was the very, very highest administrator at World War II. His name is Dwight Eisenhower. When they come to Dwight, everything, the French, the British, everyone is telling them, the Americans have to come to Europe and they need to strike the Germans. Within 5 or 7 days, we're going to have the Germans out of France and we can control Germany and the Nazis are going to be out. And Dwight is surrounded by divas. Do you have divas in your projects? What is a diva? Divas are a little bit dangerous, but if you can influence them, they are really good. Divas tell you, I am the diva singer at the opera, and people are paying for me to come here to sing. If I go out, there is no opera. Within projects, there's people like this. I am the diva of the project. If I go out of this project, the project is not going to be finished. You need me here. Do you know this kind of people? Yes. Well, Eisenhower was surrounded by divas. And everybody was telling them, hey, we need to go now. And Eisenhower said, no, we need number 10. We need resources. We are not going to invade Germany or France or Italy. We're going for Egypt. Do you know the Suez Canal? Last year or maybe 2 years ago, a huge ship, the Evergreen, got stuck in the Suez Canal and billions of dollars were lost because of the Evergreen. Do you know this? So Eisenhower tells everybody, guys, we need the Suez Canal if we're going to win this war. Wars are not won in a day or in a week. They take years, a lot of years. And it's a game of attrition. The first one that doesn't have the resources, the first one that gets tired and stops fighting, is the one that is going to lose, and it's the one that is going to tell you, I need to sign a resignation paper. And so Eisenhower tells everybody, we cannot go to Europe. We need to go to the north part of Africa. And we're going to land on Africa, and we're going to march from West Africa to East Africa to get the Suez Canal. After we get the Suez Canal, it doesn't matter. It doesn't matter. Everything else doesn't matter. I can do whatever I want. I can do a lot of exploratory missions, and also I can do value creation missions. Because I have all of the resources, and the Germans don't have the resources. Through the Suez Canal, you can get iron, you can get food, you can get textiles, whatever you want. It was in the control of the British, but the Germans took it. And Eisenhower told everybody, we need the control of the Suez Canal to get all of the resources. And after that, I can assure you we can win the war. That's why, for me, number 10 is the most important. You need the resources. If you don't have the resources, you are not going to be able to win the war. Okay, that was the last one. I was going to talk about something that